Greetings, programmers. Busted Thumbs back again. And this time I'm going to do a tutorial for those who are experienced programmers. I often say at the beginning of my tutorials and my little watch me make it videos that I use the phrase greetings programmers. And this is something I took from the movie Tron. It's a little bit of an adaptation there. And this time I probably should have said greetings experienced programmers because this introduction to Scratch is meant for people who have done a lot of programming in the past and know a lot about programming. And so I just want to put in a little warning here that I'm going to start using words that people who are not used to talking about programming may have no idea what I'm talking about when I say them. So if things like object orientation and lexical scoping and inheritance and all these other type of words that developers might use and mean something very, very particular, they don't mean anything to you right now, then I would encourage you to go and instead of watching this particular video, to go to my introductory video for beginners to Scratch. And if you feel like that's going too slow, you can always speed it up, skip ahead, things like that. But in this particular video, I'm actually focusing on people who have learned to program in any of the several other languages that are out there and are just kind of new to Scratch and just want to learn how Scratch itself works so they can educate themselves on how to work with Scratch. When I was new to Scratch, I was actually introduced to it by my daughter, who's not a programmer but was interested in learning how to program, and she had to walk me through many of the features of Scratch because even though I had been programming for many years, the way that it worked inside Scratch was completely new to me and I needed some help. So this video is really for that. It's for people who want to learn the ins and outs of Scratch, but don't need some of the introduction to the programming concepts that are out there. So when you come to Scratch, and it's scratch.mit.edu, you'd have to create an account. And once you've created an account, you'll come to a page that looks a lot like this, but won't have any projects inside of it. Rather than creating a new project, which is easily done by just clicking this new project up here, I'm just going to jump into the beginner's tutorial that I created when I did the series for new people to Scratch, new people who aren't programmers but wanted to learn Scratch. So there's two ways to see a project. One is to click on it and see how it runs, but you actually want to see inside of it. So if you're not creating it from scratch, you want to go in and just see inside, because this gives you the view of the project that has the code that comes with it. Now let me point out to you the different aspects of the window that has just popped up. This over here is your actual project. This is the code that will be running and what the user will see. If they didn't click see inside, they would just see this. At the top here is the name of the project, and then above that there's a little menu that allows you both to learn a little bit about Scratch and interact with things just as you would expect. Up here are some buttons about copying, pasting, moving things around. There's a backpack feature so that you can actually take scripts that you create in one area and move them over to another. At the top is an indication of some things about my account, and then as you can see here, we have the actual window. And let me get into the other things that you'll see. The code itself is written here onto the right, and this is just a bunch of code right now that we can go through in a little bit. But just think that here is the code written in blocks, and here in the middle are the building blocks that you would use to make that code. Those building blocks are categorized, so things that have to do with motion are in this dark blue. And I apologize if the text is kind of hard to read in these YouTube videos. I can actually make it a little bit bigger in this portion where we write our own scripts, but I can't really magnify this center portion. So if you maximize your YouTube video, you might be able to see this a little bit better. But things that have to do with motion are here, and then there's several other categories, and we'll go through each of those categories in a minute once I've shown some of the other features of Scratch. Scratch has a notion of objects. Objects are referred to inside of Scratch as sprites, and so that's what we have down here. All the objects which we create will be created as sprites. In addition to that, there's kind of a global object, which is the stage. So the stage is this thing that appears in the background. It's kind of the furthest back Z order portion of the screen, and it always fills up the entire screen. You can write scripts on the stage, and that's what we see over here. Those scripts are globally applied. They will always be running, and they always apply to the kind of the whole window. Before we get into the actual scripts though, let's talk a little bit about the way we get it to look the way it looks here. Every stage, and there's only one stage per project, but the stage has a notion of backdrops. And the backdrops are just the view that you have. So I have two of them inside here. There's a sky one, which is just plain blue, and then this desert. These icons across the top here are the ways that you can create new backdrops for your stage. There's an option to choose from a library that Scratch has. You can draw it yourself. And the interesting thing about drawing it is that there are two modes. There is a bitmap mode, which is how it comes in by default, and those will just be stored by pixel. And there's also a vector mode. And a lot of the items that you bring over from the clipboard will be vector type graphics so that they can scale out. There's also a way to upload from image file on your own computer, and apparently there's a way to import, but I've never used this from a camera. There are tools for drawing. You'll recognize a lot of these. If you have a paint program, you're going to have a lot more tools available to you, but you can use these if you like. When you switch over to vector mode, there will be a different set of tools. Objects have a similar set of items on them. So if I switch over to this object, which is a sprite, my cat object, instead of having backdrops, they have costumes. So the look, and you can see that it's alpha'd. The sprite itself can take up the entire screen if you wanted to and be this large, but you can also make it an alpha version, right? So there's a masking behind it, and you only see, as you can see on the cat here, all this alpha background isn't showing up. Costumes can show different poses or be completely different images. It's up to you. They're often used for animating. And so you switch between the costume and it provides the animation for the character. They have the exact same, there's a library you can pick new costumes from. You can draw your own, or you can upload from file, and it can be both in vector and bitmap. You can see that this one's in vector mode, and so I have a different set of tools. The bitmap stuff was over here and is a different set, and this is the set that we have. The other interesting thing to note is that on every one of these drawings there is actually a little crosshair. It's kind of hidden behind this guy, but it actually says when you place a sprite on the screen, you're going to place it at an X and Y position, and the crosshair that will show up here, and which is selected using this tool up in the upper right, set the costume center, will say where you place that. When you say X, when you say to place it X and Y, it will say where on this costume that X and Y will be. So it can be in the center if you want. That's how it is by default. A lot of the times when I'm making tiles or cards or something like that, I'll put it up in one of the corners. There's also sounds, and you can get sounds from a library. You can record them. This one's a meow that comes with this particular sprite. So those are the interesting things that come along with each sprite. Let's talk a little bit about variables, because that's one of the most important things that you can work with. I have a number of variables already created in here, and you can see that I have right now selected my sprite cat. And by the way, if you want to edit things about the sprite in general, that little I button up there will give you the ability to rename it, and will tell you about its XY position, direction, and whether you can drag it around or not. So you can always click on that to edit those. But talking about variables, variables show up in Scratch as these rounded rectangles, and this is the name of the variable, and the value of the variable can be seen as well. If you check the checkbox, what ends up happening is the variable appears on your screen. So what I've got right here is a variable, and this variable is scoped to the sprite. So it's a sprite scoped, it's like an object scoped variable, and that's why this right here came from the name of the sprite that it was scoped to. This is the name of the variable, and this is the value inside that variable. There are only two scopings for variables. There's no such thing as a local scope or a stack or anything like that. Scratch just doesn't have that notion. So if when you're sitting there and you're writing a program and you need to do like an index across a loop or something like that, there is no way to just declare like an index variable and then just walk that through. You end up having to create one on your object that is always visible to that entire object. But there is two scopes, and those two scopes show up here when you click on make a variable. One is for all sprites, and this is the global scope. If you click for all sprites, the stage will be able to see it, as will any sprite that you create, any object you have inside here. And there is a way to make multiple copies of a sprite. In that instance, when you have multiple copies, they will all be referring to the same variable. It's kind of like having a static, I guess, and a global static. If you instead make it for this sprite only, which is what most of these variables are, and the reason why that cat showed up there, then when you switch to stage, you'll see that those variables go away. Stage can't see it. Other sprites couldn't see it either. Unfortunately, they don't make any sort of color coding differentiation inside of Scratch. They're all just orange, so it's hard to tell which is which. But if you do make them visible, you'll see that here, that last clicked X has no name of a sprite in front of it, and that's one way to indicate that it's a global variable. And I'll just make that one go away again. So last clicked X and last clicked Y are global ones, and then when I switch over to cat, you'll see that last clicked X and last clicked Y are still there, but all the other ones that are local to a cat is there as well. Variables are not strongly typed. You can think of the variables as very similar to the ones you might see in JavaScript or the like. You can make them text or numbers or whatever you want to, and it will try its best to parse them as it can. And you also, when you do variable comparison, Scratch is not case sensitive. So a name like Frederick, which I use down here, will match on an uppercase Frederick or a lowercase one. And there's some other little quirks about those, but you can figure those out as you experiment. Let's talk about actually creating and doing things inside Scratch, and probably one interesting thing to keep note of is the coordinate system, because we'll probably talk about motion first. The coordinate system in Scratch is centered in the center of the screen. So let me try and oh no, that doesn't show up in the larger view. But when I put my crosshairs, my mouse inside of here, it's got a little indication down here of what the X and Y is. And when you see this on your own screen, you'll see that it starts at 0, 0 in the middle here, and X goes positive to the right and negative to the left. And it goes up to 240 and to negative 240. So there are 480 virtual pixels going across. Up and down, it goes to 180 and negative 180. Which is this is very different from a lot of other programming languages and UI frameworks you might be used to, because y goes up as positive and down as negative. So keep that in mind when you're laying things out. You'll often have to switch. When you're going to the right, you're going positive, and when you're going down, you're going negative. And that may be something that might not be used to for you. You might not be used to that. All right, so the way Scratch works, and you can see here I've got a number of programs, is there is an event that happens, and this triggers code to run. And the events, they look like this. They have this kind of bubbled look to them. When you run a program, you click on this green flag, and that means start. And so there is an event that says when the green flag is clicked. This is basically the entry point to your program. So what will happen is it'll come into here, and it will just start executing each of these instructions in line. It will do this one until it completes, then this one, then this one, then this one, as you might imagine. The interesting thing about this one that I've created right away is this is a custom, this is basically like a method, a custom method that I've created, and that's done inside of more blocks. You can go ahead and make a block, and you can name it my method or whatever it wants to be, and you can use spaces, and it's the methods themselves, or any string will do. Inside here in these options, if you click that down, you can actually add parameters to your method. So you'd say add a number input, the age, you want to compute something about the age or something like that, strings and booleans, and then you could add more text at the end if you wanted to describe it. This checkbox down here is very interesting. It says to run without screen refresh. And what that means is if you want to do any sort of like double buffering or anything like that to your UI, what it will do is it will run everything inside of that method before it goes and updates the UI on the screen. One of the interesting things about Scratch, in order to make it easier for new people who to programming, is that when there's any sort of a loop, it introduces an artificial delay when it repeats back on that loop and tries to refresh the screen in between. And they did this just because a lot of programmers were writing things that they thought would have like interesting effects of their sprites running across the screen, and they would never see it because the program would happen so quickly that it would just go right to the very end of that loop. So they just simply made it easier for new programmers to see what's going on by introducing this artificial delay. If you check that box, that artificial delay goes away, and then the rendering to the screen just happens when you're all done. So in this particular program, when the green flag is clicked, the very first thing it's going to do is call my custom block, which is to initialize variables. And I've done that over here. And like I said, the data tab had the variables in it. It also has the way of changing variables. So there's a set and a change. Set is what we're using here to initialize things, and you can type in whatever you like to inside of these. So Domingo Dom is the name and nickname, and I can use numbers if I like, which I do for these other variables. The more interesting thing here now is this ending y. I had a starting x position and an ending x position, as well as a starting y and an ending y. I wanted the starting y to be the same as the ending y to be the same as the starting y. So I could have just typed the exact same number inside there. I could have, looks like it's negative 110. I could have done that. But in order to be consistent, anytime you see one of these white boxes in here, you can actually go ahead and just drag from over here where the variable is and pop it right into there. And if you have something free floating like this, it won't do anything because it's not attached to something that starts it. To make that go away, you just drag it to the middle and let go, and poof, it disappears. When you move things around inside Scratch, they move from the top down. So if I clicked here, it's going to grab everything underneath it. If I click here in the middle, it's going to grab these, and then they'll just kind of snap right in underneath that where these little divots are inside of them. They'll snap right in there. All right, so after this program's created, you can see that I started using some of the motion aspects. There's move, there's turn, there's point of direction, there's just simply set the x and the y. Setting the x and the y is simple, it just moves it to the coordinate. The move is a little more interesting. Each sprite has a direction, and so you can see that I pointed already in the direction to the right. It gives you a little hint. These are done in degrees. If I were to have instead used the move 10 steps instead of setting the x and the y, what it would have done is it would have moved in the direction that it's facing. So because I have it pointing to the right, if I would have said move 10, it would have moved 10 virtual pixels to the right. And the reason I call those virtual pixels is that you can expand Scratch to be a full screen mode and run the program. And if you do, it's still 480 pixels left to right, and it's still, 360 up and down. So when you think of those pixels, they're not real pixels. They are some representation in Scratch of pixels. And it will scale everything accordingly to the screen that it's fit on. All right. So inside of here, we've got some motion going on. The next category in there is looks. Looks allow you to do things like put a little bubble dialog box to say what he's saying, so you can make it look like a little bit of a cartoon. You can actually show or hide the sprites that you have. One instance of the sprite object will always exist in all programs, at least one instance. So it's a very common thing to go ahead and hide your sprites at the beginning of a program because you know they need to be introduced later in your game or something like that. You can switch the costumes. If you're the stage, you can switch the backdrop. You'll see, like, if I go to stage, I don't have the costume things, but I still do have the backdrop things. Then you can see also that there are some built-in variables, and the blocks show up as these rectangles with the little divots in them, and the variables that are built in down here You can make those show up as well. So you can see that the cat has a costume number that it's working with right now. It's the second one. These variables are read-only to you. The Scratch will change those. Like we had up here, the X position and the Y position. They'll change as the sprite moves around, but you can't change them. You can only read them. Sound is kind of self-describing. Once you have sounds in there, you can play them. Um, the interesting thing about some of these sounds, almost all the blocks that you use will wait until completion before going to the next one. There is a difference with sound. When you play sound, it will start playing that sound and then it's really start playing the sound. It's not waiting until it's done. If you want to wait until it's done, that's done down here. The pin allows you to draw. So this is also a sprite-based thing. You actually have to take a particular sprite and move it around in order to use the pen, but you can set its color, tell it to put the pen down, and then actually draw. If you want to, instead, you can actually stamp the current look of the sprite onto the screen, and then it kind of draws it straight into the background, and any other sprite then will be on top of it. So let's get into something a little bit more interesting, and that's with the events. The events control user interaction. So when a key is clicked, or if the user clicks on the mouse, those events happen here. And you can see that you can put these in here, and anytime the user clicks on the keyboard anywhere, this sprite will handle that click and can do whatever code you want to. The more interesting thing is that, and I have one of these already, when the sprite is clicked, it's going to do something. It's going to check if, well, we'll walk through that in a little bit, but it's going to run some code, and this only happens if the sprite is clicked. In order to handle any sort of user event on the backdrop instead, you actually have to do that inside of stage. So you'll see that when this sprite is clicked is an option while I have cat selected, but if I go to stage, then I have a different one which says when the stage is clicked. And I did that in this particular program. You'll see that when the stage is clicked, I set the global variable of the last clicked X to the mouse X and the last clicked Y to the mouse Y, and then I did a broadcast. So method calls within a sprite were done with those more blocks that I showed earlier. But anytime you want one sprite to interact with another, or you want a sprite to interact with the stage, or a stage to interact with a sprite, instead what it does is a global broadcast. It's kind of almost like a pub sub system, where it just says, it tells everybody that there's something now that needs to happen. In this case, what I've done is I took this broadcast block over here and I brought it in, and from there I was able to type in a new message, and I can make that message a string of whatever type I want to, or whatever name I want to. And I told it to run. Now these are the two interesting versions of broadcast. Broadcast simply sends out a message, and that message allows other code to run, and all that code starts happening in parallel. But I can use this other method here which says, yeah, sure, go ahead and kick all those pieces of code off, but wait until all of them are done. All the event handlers on this broadcast event that I'm doing, wait till they all get to completion before I go on to the next step. And this is you got to be pretty careful about this, because you can easily write an infinite loop or something like that inside of those other handlers, and then the code beyond that would never get called. And there is a little bit of some debug help inside of Scratch when the program is running. If it's in a particular event handler, the entire thing will highlight in yellow. It's a little bit hard to see, but you can. But there's very little help to do in terms of stepping through through methods. There's very little other than for variables. You can show one variable for one sprite. And by that I mean, like, if you have multiple instances of that sprite, you can only see one of them. You can see the other variables, but you can only see one instance of the number of laps on the cat, for instance. So what you do is, if you want the stage to interact, say, because the only way to figure out a mouse click happened is to catch it here, you collect the information about the mouse click, and then you say, go ahead and run a lap, and then cat has to then handle that. So I have that here. When I receive run a lap, then I have to use that last clicked X and that last clicked Y that I'd set on the global variables to do things. And in this case, what it does is it kind of glides over and glides back. Now let me show you again how we do parallel programming inside of the sprite, and I did that here, and I did that with the broadcast method. This is the only way to get two things to happen at once, is to use this broadcast. So what I've done here is I want two things to happen when I want to run a lap. I want the cat to move over to where I clicked it, and that's what you see down here, is gliding to where I clicked and gliding back again. But I also want it to animate by changing its costumes. And I need those two things to happen at the same time. In order to do that, I actually created a broadcast that works inside of this sprite. And there's no such thing as a broadcast that only happens inside this sprite. What it means is I created a broadcast and I only handled it inside of this sprite. The stage got that broadcast, I just didn't give it a handler for it. So when I got to this point right here, because it does not have an and wait on it, what's going to happen is it's going to kick off the event that happens right here, and it's going to run this code and this code in parallel. And in order to catch the end of it, what I do is I set a variable that says I'm doing the walking animation to true over here. I do all the things that need to happen to move back and forth, and then you can see at the bottom here I set that variable back to false. Which leads me to a bit of a discussion on how we do looping and how we do conditionals. Those are done here inside of this control tab. You can see that I've got a repeat until. This is just a loop that terminates under a Boolean condition, and Boolean conditions are shown by these pointy blocks inside here. These should always evaluate to true or false. And I'm saying inside of this kind of C looking thing, repeat all the things that are inside of here until this condition ends up being true. And so what he's doing is he's changing his costume back and forth to have that kind of flipbook animation style to him, and doing a little wait in between, and he just keeps repeating that until this variable on the sprite changes, which happens over here when this side of the parallel code completes. One thing to keep in mind, and this is something that it takes beginners and even experienced programmers a little while to understand, is that the way that events are handled in Scratch is a little funny. It will only run one instance of start walking animation at a time. It will only run this one group of scripts at a time. So if I were to do a loop that just started sending off these when I receive start walking animation, what it's actually going to do is it's going to start queuing up my requests to do that. So it's going to say, hey, I had this thing come in a bunch of times, and now I need to run 5 of these. And what Scratch has decided to do, because a lot of times people put in infinite loops in their code because they're new programmers, is it will continue executing the event handler that it's in until it gets to a continuation, basically a yield break inside of the code. And they've defined that those yield breaks are either a wait statement such as this, a broadcast statement such as that, or the repeat of a loop. So what would happen if I called start walking animation while start walking animation was already running, is it would go running through here until it either hit one of these waits or it came to a loop end here, and then it would terminate the thread that was running this one, and it would start a new thread running another one until it hit one of those conditions and another message was queued up, if another message was queued up. And this makes it a little bit difficult in some situations, because a lot of the time you want to handle, say, when the sprite was clicked, and you don't want anything to happen, like you kicked off something, you don't want future sprite clicks to be recorded. So the temptation is to create a variable that says, hey, the sprite has recently been clicked and I'm doing something, and then at the very end of that to put everything, set it back to saying everything's okay again. And this doesn't work in most cases, because when sprite clicked works just like when I receive a message, and it queues up the instances based on whenever a user does a click on that sprite. And so oftentimes, because you want to put in something that is a yield break, it will never get to the end of the loop, and it will never set itself back to saying, to the variable setting itself back saying that it's available to run things when it's clicked again. So there's in other tutorials, hopefully I'll show how you can get around some of that. But just be aware of that. It's probably the first thing that experienced programmers run into, because a lot of times the first thing you'll do is say, hey, when my sprite is clicked, I want to run this interesting animation, and it'll have a loop or a wait inside of it, and then you'll find out when you click on it like multiple times, it's not doing what you expected. Just understand that this is the way Scratch has been written. I don't think it's the greatest implementation, but it's the way it is, and we have to deal with it. Okay, so the various conditionals are inside here. There's an if then, and there's if then else. There's a repeat, and there's a forever loop. And I encourage everybody that I teach never to use this forever loop. It is the most abused thing inside of Scratch, and I often am on the forums talking to people about their code, and in 90% of the cases where somebody's run into a problem, it's because they put a bunch of forever loops everywhere. Instead of using the broadcast events when something changes, they just simply put a forever loop and then an if statement right inside of that, or a wait until statement, and they just lose complete control over the ordering of the execution in their program. So try and avoid that if you can. There's really no need to. I've written some very big programs inside of Scratch, and I just never use the forever loop, even for like a game loop. Sensing, it allows you to check if your sprite is touching another sprite, or to see if it's touching a color in the background. It does have some things to do with video, and there is a timer. The timer is interesting. The timer is, you can actually show it. It should be running right now. I'll make this bigger. The timer is showing the number of seconds that have happened since I started the program. And you can read that value, and you can do math on that value, and you can actually reset that timer back to 0 if you want to. And it does become useful to do from time to time. In the green is the operator, so here you have your math functions, arithmetic, plus, minus, times, divide. Note that none of this is integer mathematics. These are floating point numbers. So when you do your division, it's going to be division on floating points. It also has comparison operators, which are Booleans, as well as logical ones, and, or, and not. Join is a concatenation on strings. If you try and join numbers together, you can do that as well, but it treats them like strings. Letter is basically an index into a string, which will bring a character back, and this will give you the length of the string. Now mod, they do give you the operator for mod, if that's what you need to do, and they give you the operator for round, which is very helpful since these are floating point numbers, and you'll lose precision in many cases. This last guy here is very good to do. You'll see that this gives you a lot of the operators which you might normally expect to work with: absolute values, floor, ceiling, square root, sine, cosine, tangent, arc sines, logs, exponents, things like that. And those will work on numbers. So that's most of the basics inside of here. There's only really one more topic to cover, and that is cloning. Cloning is done here inside of the control sense. At the bottom here, you'll see that we do have one event handler, and that's when I start as a clone. And you can create clones, and I've done that right here. The reason why you see 3 cats on this screen here is because I have created clones of that cat. And the way I did that is that I said when we're all started, what we do is we set up all of our variables, and then we go and create a clone. And when you create a clone, what it's doing is it's using all the exact same code that you have in here, and it's taking all the variables exactly the way that you've set them for this particular sprite and copying them. So it's almost like a copy constructor. It makes makes a brand new copy. And I handle that over here when I start as a clone. And you'll see that inside of here that I make sure every time that the clone is created that I change the variable of starting y by 100. So what that means is, because the first time it comes in, it will have a particular value and it will increase it by 100. If I were to call it again on the new item instead of the old one, right? Because I started with this guy at the bottom. If I called create clone on him twice, they would both be 100 up. But if I call create clone on him once, this will be up 100. And then I call create clone on this guy that I just created, it'll go up another 100 because it will be copying the variables of this guy and not this guy. And the way that I've done that, essentially I've used name as an ID on the clone. And what I've done is I've done a check to see that if the ID is my original guy, if he's Domingo, then I'm going to set him to Irene and then create a clone again. So essentially I've created a bit of recursion here. I've recursed back into the start as a clone, and I've made sure that my termination condition is that I only keep creating that clone if I'm still Domingo, and I changed to Irene here. So in both cases they're increasing by 100, but I'm changing the name based on this ID, which I've changed in each of them. And you can go ahead and experiment with this program if you wanted to see the things that are inside here. I hope this is enough of an introduction that you now understand at least some of the basics behind Scratch. You can build up from the building blocks, the scripts that make up the program. You know about the variables. You've seen cloning. You've seen event handlers. You've seen the costumes and stages behind things. There's a lot of examples out there in Scratch. The best way, once you've got this kind of basic foundation on Scratch, to learn more about it is to just go ahead and search for other projects and see how they've done things. But I think this is enough that if you're an experienced programmer, that it will give you enough that you can get started and start doing interesting things yourself. Hope you've enjoyed the tutorial. I wanted to make sure I just did it in one go for those of you who have some programming experience. If this was too fast for you, of course we have the beginner's tutorial, and if you want a little bit of notion of how to do Scratch programming in a real application, I have several videos that I've put up showing how I make usually games, but also that I can have some tips and tricks about some other features as well. All right, hope you enjoyed it. Please share with your friends if they become interested. And really, the beauty of Scratch is not necessarily for those of us who are experienced programmers, but it's for those of us who are experienced programmers to pass it along to those who may not be, to give them a taste of what programming can be like, so that they can find new and interesting ways to express themselves and maybe hopefully learn some more intense programming languages down the line. Thanks for watching. I'll see you later. Goodbye.